This is Saturn V, the rocket that will send 3 Americans toward the moon in Project Apollo. But this historic journey cannot be attempted without knowledge. Knowledge based on experience. For the United States, experience came by seeking answers to certain basic questions. Could a human being withstand an 8-day flight to the moon and back? Could a man control the movements of his spacecraft, rendezvous and dock with another vehicle orbiting the moon? Could he leave the protective cover of his spacecraft and perform useful work in space? Could he function effectively as an experimenter and use spaceflight to advance human knowledge? Could the Apollo spacecraft be guided and controlled during re-entry into the Earth's atmosphere so it could make precision landings any place on Earth? If the answer to any of these questions was no, it had to be known before 3 men travel 250,000 miles to the moon. And so in 1961, the Gemini program came into being as the necessary prelude to Apollo. This is the story of Gemini and its legacy to spaceflight. On Gemini, training began on Earth and in the atmosphere. This specially designed airplane was flown hundreds of times on parabolic sweeps into the sky to provide the Gemini astronauts with brief periods of weightlessness. Here, seconds at a time, the difficulties of living in space were rehearsed. Working under zero gravity, the Gemini astronauts gained experience with the equipment and techniques they would soon take into space. It took hours of training under these rigorous conditions to develop the confidence needed for operating in the space environment. The Gemini astronauts took their equipment underwater. Balanced between sinking and rising, they learned to pace themselves as they performed tasks in a condition that simulated longer periods of weightlessness. In the translation and docking simulator, they got the feel of maneuvering their spacecraft into position for docking with another vehicle. In the Gemini mission simulator, they flew entire missions without leaving the ground. Here, they learned to react quickly and correctly to problems fed to them through computers. The Gemini astronauts exposed themselves to the stresses of the space environment. They trained for emergencies, learning how to react if things did not go exactly according to plan. Parachute training in case they were forced to eject from their spacecraft. Water survival for landings in the ocean. Survival in desert and jungle. But ultimately, there was no substitute for being there. Gemini took the men and the tools and the problems into orbit. In the 18 months between March 1965 and November 1966, 10 manned missions were launched from Cape Kennedy. 16 astronauts journeyed to their spacecraft on Launch Pad 19. Virgil Grissom and John Young were first. Then James McDivitt and Edward White, L. Gordon Cooper and Charles Conrad, Frank Borman and James Lovell, Walter Schirra, Thomas Stafford, Neil Armstrong, David Scott, Eugene Cernan and Michael Collins, Richard Gordon, Edwin Aldrin. 4 of the Gemini astronauts made the trip twice. Together, these men helped thrust the United States into a new era of exploration. Gemini was a single concept with a number of assignments. It was, in a sense, one launch, one flight, one recovery.
Stand by for 10-second countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
Space is infinite. It yields slowly to exploration. In their voyages into this environment, the Gemini astronauts logged more than 1,940 man-hours of flight. Hurtling through space at 5 miles a second, they circled the Earth 600 times. In their 40 Earth days in space, they witnessed, as few men have, hundreds of sunsets on the changing horizons of our planet. Sweeping over continents in a matter of minutes, they gained a new perspective of Earth. For Gemini, equipment and techniques were developed that enabled astronauts for the first time to maneuver their spacecraft, to change their orbit, to accelerate to new heights. The first Gemini maneuvers were basic, flying formation with the spent second stage of the Titan II rocket. Then a more difficult step, rendezvous, finding and approaching another craft in space.
Okay, Gemini 6, ready to copy. Okay, P8, 06, 3500. Pass at Hawaii, Rev 4.
The first target for rendezvous was another manned spacecraft. Gemini 6 approached within 1 foot of Gemini 7. Rendezvous, a major landmark in the history of manned flight. Aboard Gemini 7, astronaut Borman prepares to take motion pictures of Gemini 6 as the two spacecraft begin their station-keeping exercise.
And we have LOS also. Both vehicles have away.
10 rendezvous were accomplished during the Gemini program. The techniques varied, for this maneuver is important to Project Apollo. The lunar module, on returning from the surface of the moon, must rendezvous and dock with the command and service module. In Gemini, conditions of lunar orbit were simulated in Earth orbit, and confidence for Apollo grew. On 4 of the Gemini missions, the rendezvous target was the Agena space vehicle. During the program, the Gemini astronauts located and docked with the Agenas 9 times, developing experience and confidence in this important maneuver. This experience is vital to the lunar mission, for the Apollo astronauts will dock twice on their journey from the Earth to the Moon and back. As the spacecraft moved in, docking lights aboard the vehicle helped guide the pilot during the final stages of the maneuver.
Okay, Gemini 8, it looks good here from the ground. We're showing tone rigid. Everything looks good from the docking. Okay, we're going to cycle our stop on switch. Roger. Flight, we are down.
But not everything always went according to plan. On Gemini 8, a thruster failed, causing excessive yaw and roll. Unable to find the source of trouble, Command Pilot Armstrong undocked. The roll rate accelerated, reaching an alarming 1 revolution per second. But Armstrong fought and won his struggle to regain control, and he brought Gemini 8 to a safe landing. On Gemini 9, when an Atlas rocket failed to place the Agena into orbit, a substitute docking target was launched. Trouble developed on the new target when its shroud failed to separate, leaving what the astronauts quickly named the Angry Alligator.
Gemini 9, Hawaii. How are you? I've got a weird-looking machine here.
Although the docking maneuver had to be canceled, the flight plan was revised so the astronauts could go on to practice rendezvous 2 more times, developing faith in their ability to cope with adversity and to learn from the unexpected.
This job is open at about 25 to 30 degrees, and both the piston springs look like they're fully extended.
On 2 missions, the Gemini astronauts actually assembled a new spacecraft in orbit, the combined Agena and Gemini. After docking, they commanded the Agena to restart its own rocket engine. On 1 mission, this space-built vehicle was flown to a record altitude of 851 miles. From their vantage point in space, the astronauts had a spectacular view of our planet. Although flight experience was the primary objective of Gemini, the program offered a unique space laboratory to science, medicine, and technology. More than 50 experiments were carried on the Gemini spacecraft. Many were repeated on several flights. One experiment was photography of the Earth. Vast areas never seen by man in their entirety were studied. More than 2,000 photographs were taken from space during the Gemini program. These pictures are being used to correct maps and to provide oceanographers, geologists, and geographers with new information about the Earth. Gemini astronauts also used their cameras to photograph cloud patterns and other atmospheric phenomena. This work supplemented information obtained from unmanned weather satellites. Hundreds of high-resolution photographs were made to provide new knowledge about the weather of the world. The astronomical sciences also benefited from Gemini, for the orbiting spacecraft enables scientists to send instruments far above the blanket of atmosphere, which filters and obscures a variety of phenomena. On Gemini 12, an eclipse of the sun was photographed for the first time from space. The results of scientific research conducted on Gemini have been made available to the world, not only helping to advance man's knowledge, but promoting a greater measure of understanding among nations. Three of the manned Gemini missions were flown to investigate the problems of long-duration spaceflight. Gemini 4 was a 4-day mission. Gemini 5, 8 days. On Gemini 7, astronauts Lovell and Borman spent 2 weightless weeks in space. These flights confirmed the endurance of man and his new spacecraft systems. They showed that an astronaut can live in space longer than is required for a round trip to the moon, and thus paved the way for Project Apollo. Using the Gemini space vehicle, the astronauts also experimented with a new technique for holding their spacecraft's attitude fixed with respect to the Earth. Normally, this requires the continuous use of fuel.
Gina's just about horizontal with us right now, and what we're going to do is put in a very small thrust.
But on 2 missions, a Dacron tether was attached between the spacecraft and the Gemini.
The tether is nicely taut now, and I think if we keep it taut, we might be able to...
The Gemini, slightly nearer the Earth, was pulled more strongly by gravity than was the spacecraft. This small difference was enough to stabilize the vehicles so they could maintain their position without use of fuel. This technique has important implications for future space missions. Perhaps the most spectacular experiment of the Gemini program was extravehicular activity. Astronaut Ed White made the first American walk in space. Spurts of gas from White's handheld maneuvering device thrust him in the desired direction.
Are you ready, Capcom? That's right, Capcom.
The floating object in the foreground is the astronaut's overglove, left behind in the spacecraft.
I've exhausted the fuel now, but I was able to maneuver myself out front of the spacecraft back. Maneuvered right up back on the back of the adapter. Took the back Jim, came back into his view. The only thing I wish is I had more. This is the greatest experience I've insisted ever.
In contrast to Ed White's successful 20-minute walk in space, the next 3 men to venture outside their spacecraft encountered unexpected difficulties. Although some useful work was accomplished, including on one mission, the historic retrieval of a scientific experiment left behind on an earlier flight, workloads were higher than anticipated. The astronauts had trouble stabilizing themselves outside the spacecraft. All 3 walks had to be terminated early.
Yeah, let me hang on to you. I got to rest here a minute, though. Okay. Yeah, I'm focused. How much tether you got up? Oh, I'm hanging on to you right now. You want me to hang on
The
to you?
difficulties encountered on these missions posed profound problems for future space exploration.
I'm hanging on to you right now. Tight. Don't have any out. Well, let's go get that tether. Let me have some tether out. Oh, okay. I'm ready to let you go.
So another more careful and more tightly controlled test was prepared for Gemini 12, the last flight in the program. Prior to this flight, astronaut Aldrin trained intensively underwater, pacing himself for his work in space. The tasks assigned to him were designed to compare the difficulty of working in a weightless environment with work under normal gravity. On Gemini 12, the problem of excess workload was overcome by frequent rest periods and the use of improved body positioning restraints, such as waist tethers, handholds, and foot restraints. Extravehicular activity has important applications to the lunar mission. Apollo astronauts will leave their vehicle and install scientific equipment and collect samples on the surface of the moon. This requires experience working in pressure suits and performing tasks in the near vacuum of space. The success of EVA during Gemini will also give Apollo astronauts returning from the lunar surface the ability to board their command module, even if they are faced with docking difficulties.
I think maybe I'll move this tether out to the other ring. That looks a little better.
Gemini provided more than 12 hours of experience in extravehicular activity. The training, the caution, the slow accumulation of facts paid off. Man can work in space. On all Gemini missions, a major objective was to develop re-entry flight path and landing control, so the spacecraft could land at a specific place on Earth. This required the development of new techniques for guiding and controlling the re-entry of the spacecraft. This is the view from the spacecraft window as Gemini re-entered the Earth's atmosphere. Glowing particles boiled off the protective heat shield to leave an incandescent wake. During Gemini, 10 manned spacecraft made this fiery re-entry into the Earth's atmosphere. Gemini 12 was the last. Its re-entry in November 1966 climaxed a program which will really have no end. For Gemini is illuminating the future. Of first importance is the fact that Gemini sent more men into space and kept them there longer. Gemini multiplied American manned spaceflight experience 37 times.
There it is. That's it. 12, Houston, we've got you on the boob tube. You look good.
Gemini, an open program, helped further promote international cooperation in space. People in other nations not only witnessed Gemini as it happened, but also helped accomplish the program's objectives, showing again the necessity for international cooperation in the peaceful exploration of space. Gemini also leaves as its legacy a greatly expanded science and technology, proof that government, industry, and the scientific community can work together to translate man's boldest dreams into action. In the front ranks of the bearers of Gemini's legacy are the astronauts themselves. These veterans are now ready to face the challenge of Apollo. Apollo, with its new questions, new problems, and longer, more difficult voyages. But after Gemini, one question no longer need be asked. Now, we know it can be done.